Yeah, camera on everyone. How to do this thing? Anyone got the answer for this?
No, sir.
See, this thing I taught you in central mass and rotation, right? Moment of inertia. Whenever you see cavities, there is only one technique. You take the full sphere, minus take that small sphere, the cavity. So if this is O, this is P, this is O dash, and this is P. This is O dash, and this is P. Now, the field here, let's call it E1 bar. This will be K, Q, OP bar by R cube. So this can be written as Q by 4 pi epsilon R cube OP bar. And we know the charge density rho is nothing but Q by 4 by 3 pi R cube. So from here we can clearly see this is nothing but rho by 3 epsilon OP bar. Same way, if I take the field here, E2 bar, this will be K small q by small r cube O dash P bar, where small q is the charge of the sphere and small r is the radius of the small sphere. So this is also equal to Q by 4 by 3 pi small r cube. Charge density is same. So this also would turn out to be so I am assuming this sphere ka charge is capital Q and R. I am assuming this charge is Q and smaller. So this is rho by 3 epsilon O dash P bar. So the field at point P is simply E1 bar minus E2 bar, which is rho by 3 epsilon OP bar minus O dash P bar, which is rho by 3 epsilon OO dash bar. Vector actually, if you see, this thing is like OP bar. This is O dash P bar. This is OO dash bar. So OO dash bar plus O dash P bar. Triangle of vectors is OP bar. So you can substitute there. OP bar minus O dash P bar, OO dash bar. So let me show you the final result. I'll turn the page. Quite a good result to remember. Same thing we'll see in gravitation again. So whenever you have a sphere with a cavity, if this is O, this is O dash. The field will be parallel to this vector O dash, and the field ka magnitude is constant. This is how the field lines will be. So E inside, you need to definitely mug up the result. Rho by 3 epsilon O dash bar, constant vector it is. Example, let's say this is O, this is O dash. And let's say O dash is R by 4. Anywhere in the cavity, okay? It is not a, if you see, we have taken a random point P there. So the field is rho by 3 epsilon. O dash ka length is R by 4. And the direction is O dash cap, unit vector. So it actually depends on the distance between the two centers. You can take any point in the cavity, but the field eventually will depend on the distance between the centers. So you have to multiply with the magnitude. So just don't think rho by 3 epsilon. It is rho by 3 epsilon into distance between the centers. Do have a look at the derivation. So that final result is important.
How big the cavity is?
You tell me.
It won't matter as per the formula.
Won't matter. That's why, na.
So if we make the cavity extremely big,
make it.
It still won't matter.
Now, in this derivation, yeah,
it will become like a thin sphere, no? If you make the cavity extremely big.
That means you're saying O dash is 0.
Oh, no, yeah, okay, समझा. Become a thin sphere.
क्या फर्क पड़ेगा? मतलब you make it anything you want. Let's say this is O. You make such a big cavity like this. This will be O dash. If they overlap, so then anyway it is 0.
Yes, sir. समझा.
Remember this thing. See, this is what I was trying to teach you guys. It is not specific, this formula. The moment you hear the word, something has a cavity, this is the only technique that you know, isn't it? And this is not the first time. If you see, when we did center of mass for cavity problems, the logic was the same. Whenever you had a cavity here, we added them to fill up this gap. And when we did rotation, we did the same thing. There is no other way for us to solve other than using this logic there. You had a cavity, we did the same thing. Take a full sphere, take a small sphere, we subtracted it. The idea is that you take a full one, take a small one, subtract them or add them to get that whatever shape you need. Now that formula will be different for different chapters. Same thing you will see in magnetism, same thing you will see in gravitation. Idea is the same. Clear?
Yes, sir, clear.
Next one. Yeah, that's the result there. What about this guy? Anyone got an answer for this? You sent this, okay. Let's see. How do you approach this? Listen carefully. This is again another standard result. So we take a sphere with a small hole. So this plus again that small piece which you have taken, if you add them, you will get a full sphere. Now what I will do, I will choose a point very close just inside the hole and point B just outside the hole. A is just inside. B is just outside the hole. Now we know the field inside the cavity EA is 0. The field outside is KQ by R square. This can be written as Q by 4 pi R square epsilon. Charge by area is sigma by epsilon. Okay. Now for this guy, this is EB, this is EA. Remember, it's a small positive charge sheet, so the field will be away from the charge. Here, due to this shell here, this would be EB, this would be EA. Let me write it as 1 and 2 actually.
So inside the first shell, EA कैसे होगा?
Patience, Ishan, patience. If you wait till I teach till the end, you will know everything. So here, if let's call this thing, let's call it E1, let's call it E2. Let's call this thing E3 and let's call this thing. This is also E3 only. Actually, if you see, this also will be E1 only. If you see, because they're very similar actually. Now, see, what you're doing is, you took that small sheet, since A and B are equidistant, on that side and this side, the magnitude should be same. Now here for the shell, the A and B are again so close. What is this E2 actually? E2 is the field near the hole due to the remaining sphere. And since A and B are so close, we can say they're almost the same thing. This part is clear. Ishan?
I didn't get the part where you say A and B are the same thing. A
Because
is
they're the
inside and
same
is
thing.
outside, no?
So
So
for this
field is
shell, there's a whole record here.
okay in that case. Yeah,
In
हाँ
this
ठीक है
case, if you
understand.
see A and B both have the same field because you're taking field due to all these guys, isn't it?
Yes, sir.
Now here at point A, so this is point A, this is point A, this is B, and this is B. Everyone clear with this part here and this part here?
Yes, sir.
Yasha, Saina, Vartika, Neil. So here, if you look at point A, so field at A is E1 minus E2, but this is 0. That means E1 should be equal to E2. Field at B, again, due to both of them. So basically, we're finding field at A and B due to this shell with a cavity, shell with that small hole and that small sheet, which is E1 plus E2, which is sigma by epsilon. Since E1 is equal to E2, we get E2 is equal to sigma by 2 epsilon. Let's see what it means. Do have a look at this. So what we found is, meaning it kind of, now it makes sense actually if you think about it. Due to the total thing is 0, that means if you make a small hole, whatever field this guy is generating, the remaining part also should run the same field in the opposite direction. That's why it is becoming 0, right? And this is something which we proved last time, if you remember. This one. I have just taken this point so close, the angles will still be same, right? So the field due to this small piece will be equal to the field due to everything. Any doubts on this logic here? Great. Why are we doing all this? Because if you take this small sheet here, the force, F is the force on this small area due to remaining shell. Isn't that how you find the force between two systems? You want to find, because there is a positive charge everywhere on the shell, they're getting repelled. because of which there is a force on this small piece. So on that small area, the force on the small area due to the remaining shell is what? Field due to the remaining shell. You should not take your own field on yourself. Are you getting it? Field due to remaining shell. Because the total field, though I know, total field is this thing, kq by r square. But this field will also include field due to that small sheet. I hope you're getting the point. Whenever you say force between two charges, you should not include your own field on yourself. So it's a force field due to the remaining shell into charge on that small area. So field due to the remaining shell is E2. The charge on that small area is sigma into dA. And if you divide force by dA, that actually becomes the pressure. And E2 is sigma by 2 epsilon into sigma. Sigma square by 2 epsilon. This quantity is called field pressure. Quite a useful result, right? You can put 2 stars, 3 stars. Means whenever you take a shell, because of the positive charge on the shell is repelling, and because of which you generate a pressure on the shell, which is given by sigma square by 2 epsilon. Later on, we are going to prove this. The result becomes even nice, interesting for conductors. So here I proved it for a shell, but for conductors, it is even special. You take any random shape. So till now, this is the second type of pressure you studied. First thing is the fluid pressure. This thing is called field pressure. Later on in modern physics, we'll study something called radiation pressure. So you'll have 3 pressures till now in everything. Everything works, huh? Projected area, whatever you learned in fluid mechanics, everything works. This is the pressure on the surface. Is sigma square by 2 epsilon. This is valid for conductors for any random shape. For conductors, for any random shape. But if you take insulators, it's only spherical shell. Valid for uniformly charged shell. We derived this only for a shell. Because if you take any other random shape, you don't know this formula, right? Kq by r square won't come for any random shape, isn't it? So that is the reason this formula we derived works only for if you're taking valid for uniformly charged insulated non-conducting shell. Yeah, you can just say shell that works. But if it is a conductor, it works for any random shape. Conductors are special. We will talk about them in Gauss laws. Because field inside a conductor is 0. We will prove that later on. I hope you're getting this point, everyone. So if you have a shell with a charge, because of its own charge, it will repel. It's like you beating yourself, right? And because of that, you generate a pressure on the surface. Now what to do? Then the question got over. Now this question becomes exactly like this question, isn't it? Instead of using pressure due to the gas, we will use pressure field pressure. So now the question becomes, you take FBD of half shell. The pressure is pushing it everywhere like this. So this force would be pressure into projected area. That's what I'm saying. Max doesn't know whether you're talking about field pressure or you're talking about fluid pressure. Sigma square by 2 epsilon into pi r square. So all this will generate a tension on the circumference. Just like picking a coconut. So from here we get tension is equal to sigma square by 2 epsilon into pi r square. So B is your breaking stress, which is tension by area. Which area? Area where the tension acts. Which is tension by 2 pi r into T. Neil, clear with this? Yeah, do focus. Please ask me if you're confused with anything. And there, substitute T ka value there and you got your answer. So this becomes an electrostatic elasticity question, isn't it? So once you got this point of field pressure, question simply becomes elasticity question, fluid mechanics question. Have a look at this thing. I hope the proof is clear. So basically, there is a pressure inside a solid sphere. I think I gave that also homework, na? Did you guys do this thing? Force between upper and lower hemisphere. How do you do that? It is easy only. You want force between upper and lower hemisphere? We calculated pressure is rho square by 6 epsilon into r square minus x square. So at a distance x from center, we will take a thin ring. I didn't take that properly. Like this. With thickness dx. So what is the force acting on this small ring? The force acting on this ring is pressure into area, which is 2 pi x into dx. So if I integrate this, won't I get the force on that entire disk? This is the force on the upper hemisphere. Because tell me, where are you getting this pressure from? That is the pressure because of the full sphere. The force on the upper hemisphere would be integral force on the ring. That would be rho square by 6 epsilon r square minus x square 2 pi x dx from 0 to r. That will give you the answer on the force on the upper hemisphere. Now here, the thing is, so this will give you the answer. So here you can put a small note. So if you choose actually, because the question is force between upper and lower, but here we are considering even force due to these points here. So what happens is, force due to particles within the upper hemisphere will cancel out, isn't it? Because they're internal forces. So it works out. So you can find the net force on this disk, which will be the force between upper and lower hemisphere. Because force due to particles within the upper hemisphere become internal forces. And when you take integral, the internal forces also will add up and they'll cancel out. The reason to mention this is, when you calculated pressure, what did you calculate? You calculated pressure at this point due to everyone, isn't it? But the question is, find the force between upper and lower hemisphere. That means when you're calculating the pressure here, you're calculating due to these guys in the lower hemisphere and these guys in the upper hemisphere. But by Newton's third law, whatever you're exerting, this also will exert on the same thing. So when you add all the forces on the upper hemisphere, so these internal forces will cancel out. So what you get is end of the day force between upper and lower hemisphere. And if someone got confused with that, or else straightforward answer, you have to just integrate. That would be a pretty tough question. Matlab, this will be a proper advanced question. The first part and the second part. They'll ask you something like this: find the pressure and find the force between them. This is the level of advanced questions you can expect. Paragraphs. Clear with this pressure thing? It looks like more like fluid mechanics, no? No? Pressure. Doesn't give you a feeling of electrostatics. Yeah, welcome to life. Next one. Someone said 32 ka, 38 ka half shell. Okay. Can I go ahead? Here. This thing we did an elasticity, na? Next page कुछ है ही नहीं रे, यही था last. Previous page you mean to say? क्या चाहिए आर्यन? Got it, na? Yeah. I hope all clear with this thing. Next thing. Perfect. There are a few more varieties, but then we can do them in gravitation actually. But I think we can, let's do one or two more varieties. So this is plus Q, radius R, uniformly charged. Doesn't matter actually. But okay. We have 4Q, 2R. This is also uniformly charged. Center to center. This distance is 12R. Now from the surface here, minus Q and mass M, you projected with speed U along the center to center. So find the minimum speed so that this thing goes from this sphere A to sphere B. So particle is projected from surface to surface. Along a line joining centers. Find U minimum so that it reaches the other sphere. How do we do this?
But it's hollow, right?
फर्क नहीं पड़ेगा. It is going surface to surface ना.
अच्छा, right.
तो hollow या solid तो same ही होगा.
Sir, after a certain point, we automatically go towards the other sphere, right?
Okay. So what is the answer? Not a good answer, na?
That is me creating a problem.
So can I just like send you a picture of the equation or something?
देखते हैं ना. I'll show you now. Because the answer इतना ये नहीं है, मुझे भी याद नहीं है. I just made up the numbers right now. I just know the basic idea of the question. So the catch in the question is, let me tell you a small story. Now, whenever we launch a rocket from Earth to Moon, right? So initially the rocket is like this. So it is going like this, buzz, and after some point, they reverse the rocket, and then buzz, it lands. Why do we reverse the rocket? This is what happens whenever you want to land on Moon or any planet. The rocket keeps going. At some point in the middle, they will be rotating it 180 degrees, and then it goes off like that. So it enters the moon. No, we don't want to enter the moon orbit. We want to go and land on the moon.
So that way, able to land on the moon. Otherwise, it will crash on.
Or else you think it will go and become like this. Okay, but there is a reason for that. See, the thing is, initially at some point right here, till this region, the Earth ka attraction is stronger than Moon ka attraction. So there is one particular point, a null point, at which both the force due to Moon and Earth becomes equal, isn't it? So once you cross this point, the gravity is actually pulling you that way, meaning up and down will reverse, isn't it? So if you want to land the rocket safely, you have to slow it down this way. But imagine you just want to send a nuclear missile to Moon and just blast it. Then, if you can send the nuclear missile till the null point and give little velocity, won't it automatically get pulled away Moon?
Yes.
You're getting it? That means your job is not to send the rocket till the Moon or the missile to the Moon. If you can send it till the null point, your job is done. So one thing is understood. This question, when you see, I'm sure you all realize you have to use work per energy. And when you use work per energy, we always define state 1 and state 2. So this is state 1. Now, if you think this is state 2, that's your mistake. You need not launch the rocket till there. So there is somewhere here a null point. That's your state 2. Because once you cross this point, the force due to 4q is so strong, automatically it will go and land, right? I hope you're getting the point. This thing in chemistry, tell me one thing, in chemistry, actually, if you try to do this, from this is state 1 and this is state 2, you will get answer imaginary. You'll get an imaginary answer. You'll get v is equal to root over something negative inside. If you didn't get that, you goofed up your calculations. Or maybe you set up the answer. The reason is this. In chemistry, now you study it like this. If these are the reactants, these are the products. Why doesn't the reaction happen automatically?
Activation energy is needed.
Yeah,
Need
so
an
there is
activation
something called
energy.
activation energy. So basically, this is your null point. You need to supply energy to reach the null point. After that, it goes automatically. You need not do anything. Are you getting it? So this would be the statement there. If particle reaches the null point, with small velocity, the 4q will automatically attract it and it will land automatically. 4q attraction, 4q will automatically pull it towards it. Therefore, we just need to reach null point. You need not go till 4q. So null point is your state 2. So state 1, state 2. What is energy in state 1? Kinetic energy, half mu square. Potential energy, kq by r. Potential plus k 4q by 11r into minus q, isn't it? Potential into charge. You should take the potential due to this guy and this guy. When you say this thing, I taught you in the drinks ka question also, if you remember. When you say potential at a point, you take due to everyone. And when you say state 2, we have to calculate the null point. How much is that? Let this distance be x.
So it's 3R, I think. मतलब 4R if you take it from there.
ऐसा कुछ आएगा, हाँ. kq by x square is 4kq by 12r minus x whole square. You get 2x is equal to 12r minus x. 4r. So that is 4r. So this guy ka kinetic energy is 0. Potential energy would be kq by 4r plus, I'm writing potential, k4q by 8r into charge is minus q. E1 is equal to E2, conservation of energy. This will give you U ka value. This is U minimum. I will leave the working to you. In this question, that is a major trap. If you directly take this point as state 1 and this point as state 2, you would have got an imaginary answer. Because the final energy is less than initial energy. The system would have gone automatically, but there's an activation variable. Clear with this? So next time when you're launching, nuclear missiles to moon to destroy it, you need not actually send it till the moon. Send it to the null point. After that, they go off automatically. And now you know why they reversed the rocket. Yeah, meaning that is also a valid reason. You will go and land on the thing and you'll get stuck on the moon. So rocket gets destroyed. Check it out. So this is one good model, not a tough question, but yeah. Clear? Udayan, clear with this? Clear, na? Vidyut, Rehan, Ali, Aditya? Great. Anika, clear, na? Next thing. Self-energy. Alright, I gave you guys one more homework question, right? Yeah, this one. You guys did? Forgot?
Sir, it was in the middle, so I missed that.
Aryan sent it. Okay. So do it again. This is a pretty good one. Friday discuss karte. This is really worth trying. Answer I don't remember. But Aryan, I'll check it out. I'll check it out and tell you. Let's get back to this. So this is self-energy. What is self-energy? So basically, it is similar to potential energy. What we define potential energy as? It is the amount of energy required to assemble a system by bringing individual charges from infinity. So it is same as potential energy, but we are talking about a continuous body. So basically, it is this is the amount of energy required to assemble a continuous distribution of charge. Basically, if you want to create a sphere, hollow sphere like that. By bringing charge from infinity. So let me show you one. So I want to create a hollow sphere. Remember these things, these derivations again we will not repeat it in gravitation. Exact same things, we'll just change the variables there. So for a hollow sphere, so this is the idea there. So initially, so you want to create a hollow sphere. There is nothing here. There is no mass. Now you're taking no charge. So we have a shell here without any charge. You take a dq charge and dump it on this shell. So after some time, this whole shell will become positive charge. Means you're bringing dq charge, dq charge, dq charge, and you're distributing it over the surface. So a small charge is brought from infinity and it is distributed uniformly on the surface. And eventually you'll create a charge with a charge plus q. This is how you created this sphere. Meaning the system really doesn't care how you created it, but end of the day, the answer should look same. You're getting what we're doing? Now see, when I bring this dq charge, which is positive, you think all these positive charges will keep quiet? They will repel, right? So you have to forcefully bring it and keep it there. That means you have to do some work, isn't it? You're getting this? So it's like if you have a classroom, you must have noticed this. First 3-4 people will aram se go and sit everywhere. But once the class becomes half filled, literally people have to go and people have to tell them, "Yare, move na, give me some place to sit." Even though there is a place, people, prefer to sit one person per bench. I mean, just imagine if there is a bench vacant here, right? Bench vacant here, bench vacant here, and bench vacant here, and someone is sitting here. If you try to go and sit here, everyone look at you weirdly. Getting it? Even you will feel weird to go and sit beside that person. That person also will look at you like you don't find any place here. There are so many empty benches. So something similar. Even charges don't like to stay together. So this is your intermediate stage. So what is the work done? So small work done is the change in potential into dq charge. So what is change in potential? The shell ka potential is kq by r. Infinity ka potential is 0. V infinity is 0. V shell is kq by r. Meaning at this instant you have already accumulated charge plus q. So the total work done by external force would be integral k q dq by r 0 to capital Q. You end up with k q square by 2r. And since there is no change in kinetic energy, this is change in potential energy. Simple proof. Let me write down the result. Quite a useful result. Meaning if you construct a hollow shell, you need to give this much energy, or vice versa. If the hollow shell breaks into pieces and flies off, you'll get this much energy back. Hollow charged shell. Meaning, think about it. If there are two particles, I am saying potential energy is kq and q2 by r square. On a shell, so many charges are there. They will have their own potential energy among themselves, isn't it? So if you have a shell with a charge plus q, again, remember we derived this for uniform charge distribution. So we'll just write U self energy. That's why we call it self energy. It is an energy due to your own particles. Is k q square by 2r. Quite useful. Huh? We're going to use this a lot in Gauss law. We're going to use it in some time. Do have a look at the proof. You can use the same logic for gravitation also. It works. This is called self-energy.
So, but in gravitation will always be negative, right?
So minus an aega. That means you need not give actual energy to form it. It will release energy whenever it forms.
Yeah.
So to separate them, you have to provide energy. That is the meaning of negative sign. All clear with this what we did? So as you put more and more charge, the repulsion becomes more and more. So it actually becomes more and more difficult to make a sphere. That means if you construct a sphere of Q and a sphere of 2Q, the 2Q sphere will require 4 times more energy. Q square function.
So small doubt.
Bolo na.
If the sphere breaks into half and then other halves fly off to infinity, so the same energy will be released or different?
नहीं है ना सेम एनर्जी अभी वो हाफ स्पीयर का भी कुछ तो होगा ना सेल्फ एनर्जी तो you change
वो
in
नहीं होगा।
potential energy is kinetic energy ना
Yeah, no, the kinetic energy is always there. वो नहीं हमने consider किया।
मतलब meaning you're
Explain that.
saying नहीं you're saying they will break and they'll fly off ना
I will move slowly to infinity.
मतलब someone has to hold them ना
Yes.
why will
So
they
the
go
release
slowly
energy.
when both are positive both will repel each other right
So the release energy will be the
energy
same
तो
as
release
the
होगा
conserved
नहीं
energy?
same नहीं होगा तो logically सोचना when you suppose if every particle flies off to infinity even at infinity also these two are not interacting na but if you break into half so these people are still together isn't it I don't know the potential energy of half shell it is not half of this
It won't be half of that.
वो because
Q by 2 if we integrate.
half नहीं होगा।
अरे गॉड देन ये फॉर्मूला वैलिड नहीं होगा ना रे KQ by R हाफ शेल के लिए
Yes, sir. हाँ sir,
Makes
but
sense. Okay.
बेसिकली क्या होता है ना WC when you take two half shells ना the way you guys are saying there are actually three energies here one your own self energy and the interaction between these two interaction energy total three components आ जाएगा and I can't find that symmetry नहीं होगा half shell is not symmetrical
if we find the interaction energy, we cannot find the self energies.
then you can find find and tell me
So with that we've already found na, that question. If you just make R1 equal to R2, which we did earlier.
अरे वो फोर्स है गॉड
अच्छा, right.
वो फोर्स था एनर्जी नहीं है एनर्जी इज मोर मेस्ड अप फोर्स फिर भी हमने प्रेशर भी फाउंड द प्रेशर एंड वी यूज प्रोजेक्टेड एरिया एंड वी फाउंड इट ना
Yeah, right.
because of projected area life became easy energy में there is no concept called projected energy मतलब I don't know how to imagine that also projected energy maybe we can say projected money mom gives 200 rupees to buy something mom only gets 100 rupees ka goods remaining 100 rupees is gone projected into air or projected into your tummy maybe a Cadbury chocolate additional कभी हुआ mom gives 50 rupees it costs you 44 rupees remaining 6 rupees never comes out but I think maybe yours is the last generation I guess so went to a shop and brought something did you guys ever do that went to a general store brought something I think now after your generation I think it is gone अभी सब Swiggy में आ जाएगा Swiggy Zepto so there is no concept of sending a kid to the shop you should see how much we used to cry हाँ मुझे क्यों जाना है send brother send sister every time I only go so yeah you guys do this thing we'll do this as a question self energy of a uniformly charged sphere the results are important mug it up exam you won't have time to derive this the reason why I'm teaching you derivation every time they won't ask uniformly charged sphere if it is an advanced thing they will say charge density rho is equal to rho naught r find the self energy and you'll die then the integration will work so you should know both the ways so get this it's a uniformly charged sphere idea is the same I'll give you a little hint see so initially there is nothing here so the difference is this time when you construct the sphere q and small r so when you bring dq charge you just don't keep it at one point you create a thin shell So you increase the thickness by dr. So this dq increases thickness by dr. You're getting it? So every time you bring dq from infinity, spread it over a small thickness. So keep on adding. It's like an onion, layer upon layer, layer upon layer, layer upon layer. Eventually, you will get your full sphere. I hope you got the idea here. So in the previous case, right, hollow shell mein radius was always constant. So you're putting the charge only on the surface. But here the radius is also changing as you put more and more charge. Because you have to create a solid sphere. Think it's a good one. Self energy of hollow shell here. Basically, what we did is the potential on the surface, potential at infinity, the difference into charge is the work done, isn't it? And then we integrated that work done. You have to do something similar here. You did try. I'll be back in a minute. Hmm. 3 square by 5r. Yeah, that looks right. Abhinav, Anusha, yeah. Let's see how to do that. So what is dq here? So dq is total charge by total volume, basically rho, into you're creating that small thing, na? So 4 pi r square into dr. Agreed? So you're not actually bringing same amount of charge every time. Every time you increase the thickness, you have to bring more and more charge. So this is the amount of charge you're bringing every time from infinity. And what is the potential on the surface? Potential on the surface is k small q by r square. Small q by r. And what is small q? Small q is k by r total charge q by 4 by 3 pi r cube. Unitary method. 4 by 3 pi capital R cube as capital Q. 4 by 3 pi small r cube will be how much? 4 by 3 pi will cancel. You end up with kq r square by r cube. That is the potential on the surface. And here 4 pi will cancel. 3q r square dr by r cube. You're done. The small work done will be potential on the surface. The potential difference minus v infinity into the charge which you brought from infinity. So the total work done will be integral kq r square by r cube 3q r square dr by r cube. This goes from 0 to r. I know the answer, but you can solve this. 3kq square by 5r. So the self energy of a solid sphere. This is the result. So the reason why we call them self energy is because the interaction between its own charges. Have a look at this. Did you ever transfer money from your own account to your other account? In the remarks, you write it as self. Or if you ever gone to a bank to withdraw money, and if you're withdrawing, taking money from your own account, on the top it will be written self. We have never gone to a bank to withdraw. I know. We are also the last generation. Now to all internet banking, UPI, Google Pay. Clear with this? Nokia mobile will become ancient. But if you think about it, Nokia mobile was actually not that old. It was just one generation old. 2006 and 7 Nokia mobile matlab you had the most powerful thing, technology in your hand types. Now the people look at it so weirdly. And I'm the brand ambassador of Nokia. I have to keep telling everyone, throw your smartphones and get Nokia mobiles. Even yesterday for your juniors PTM, I did the same. All parents are looking at the kids like this. I asked them this question. I said, how many of you want to go to IITs? Everyone rose their hands. How many of you are ready to sacrifice your phone for IITs? They can't keep the hand, they can't put the hand down, they're stuck. It was fun to see their faces yesterday. Parent is looking at them, abhi haath upar karega, niche karega types. So there is one guy who was trying to put it down. His mom was catching and pushing up. Nahi, haath niche nahi aana chahiye types. Hey, it was fun. Clear with this? Let's see our question. So we have a solid sphere plus q, radius r. This is covered by a hollow shell plus q 2r. Find the total energy of the system. When I say total energy, meaning if you create this system from scratch, what is the total energy of this system? Let's get this. Mm, 8kq square by 5r. Okay. Let's see. Anyone else got the same? 8kq square by 5r. Okay, now if you see in this thing, there are 3 parts here. First, let's do like this. So construct the solid sphere separately. Construct the hollow sphere separately. So this guy is 3kq square by 5r. This guy is kq square by 2 times radius. Be careful. These are self energies. Now what you're trying to do, now take this hollow sphere. So this solid sphere, you're trying to bring it from here and trying to keep it here. Agreed? You're getting
If
it?
I
You
do
created
it
both the
the-
systems.
I
Other way
do
also
it
you
the-
can do.
It would be the same.
mean,
no?
सेम आना चाहिए ना, चेंज क्यों होगा?
Yes, yes.
So यहाँ पे v infinity में potential 0. Now here we are taking potential inside the hollow shell. You will take potential due to the solid sphere on the hollow shell.
Yes, yes.
Potential inside the shell is what? K, the charge by the radius. If you take solid sphere तो वही आएगा ना, kq by 2r.
Yes.
So this is called interactional energy. So after assembling the systems, when you try to bring the solid sphere inside the hollow sphere, they will repel each other, right? The hollow sphere won't let the solid sphere come inside. Meaning, assume somehow it is just coming inside. So interaction energy. This third part is called interaction energy. This is the energy required to bring the solid sphere inside the hollow sphere. You can do vice versa. You put the solid sphere and bring the hollow sphere. This should be potential difference, which is kq by 2r minus 0. And how much charge you bring? Plus q. So this is kq square by 2r. This is your interactional energy. I hope you're getting this. Solid sphere, to create solid sphere, you require some energy. To create hollow sphere, you require some energy. If you try to bring these two close, they're not going to keep quiet. They'll repel each other. So to push them against each other, you need some more energy. So the total energy of the system will have 3 components. Therefore, the total energy 3kq square by 5r, kq square by 4r. These are self energies, and kq square by 2r. So if someone asks you this question, how much energy is required to separate them? What is the answer? Interactional energy, isn't it?
Square by 2r.
2r. Only the interaction energy is necessary to separate them. You want to destroy everything into pieces and take it to infinity. Then you need total energy. I hope everyone got this thing.
Yeah, sure.
Clear? Next one. We have a conducting shell plus 2q, 2r. We have another shell minus qr, conducting shell. Both are connected by a wire. This is the switch. This is the symbol for switch.
So
They're
can
very
show the
far.
previous page.
Previous page.
Okay, thank you.
So they're connected by this is a conducting wire. And they're very far. Matlab they're not interacting with each other. So when switch is closed, find the final charges and the heat produced. Okay. No, you just have to find the final charges, not ratio. Root 3 नहीं आएगा रे. How are you getting root 3? Potential energy is kq by r. Did you take r square क्या? Remember in the beginning I taught you in while charges, whenever you connect two conductors, the charge will transfer till the potential becomes same. Now exam they can ask you this question also, how much charge went through the switch? So let's assume q charge went away. So this guy ka charge will be 2q minus q, and this charge will be q minus capital Q. You could have taken q1, q2 and would have solved. But this is also a possible question, how much charge flows through the switch? Since they're very far, they don't interact, so potential should be same. So this potential will be k 2q minus q by radius. Radius is 2r. Be careful. Potential energy ka formula is k q by r. This should be equal to k q minus q by r. 2q minus q is 2q minus 2q. Q is equal to 4q by 3. That means the final charges are 2q by 3 and q by 3. Yeah. Those are the final charges. What about the heat produced? Heat produced is nothing but change in self energy. Think about it. Initially, you had some self energy. Finally, you had some self energy. So, what happened to all the difference in energy? It must have gone somewhere. So, what is the, so we are writing E initial minus E final. So, what is E initial? So, E initial is this guy ka self energy is how much? I'll do one thing, I'll do it on the next page again. So, initially, your system is like this. Finally, your system is like this. So, 2q minus q. 2q by 3 and q by 3. So this guy ka energy is k 2q whole square by 2 times 2r, kq square by 2r. 2r is a radius. This is k minus q whole square. So plus or minus won't matter. This is your initial self energy. Yeah, it's a little lengthy with calculations, but yeah. K2q by 3 whole square 2r plus kq 3 whole square by 2r is E final. You are done. So it will be, so initial energy is more than final energy. So the difference must have gone somewhere. You won't get zero, right? Remember one thing, I'll tell you one simple thing. See, whenever charge flows, heat will never be, there'll be always, energy lost. Because simple logic here, a system will always try to achieve a state of least energy. That means it will always try to lose energy, and that's why charge is being transferred. If there is no loss of energy, that means the charges have not moved only. The system is already at the most stable state. I think you can argue like that in terms of energy. KQ square by 3R, yeah? Okay, I don't know. So Ishan says we got a KQ square by 3R. So you can verify the answer and check. But 14 by 3. Yeah, I'm not sure. Numbers don't look that great, but I will leave it to you guys. You can check it up. I trust your calculations. This indirectly implies I'm lazy. So you guys do it. I did the whole problem.
So
Arjun, you got
if
something.
they were like close to each other, it would affect only the second part, right? Not the first one.
पूरा mess up हो जाएगा. Close to each other, पूरा mess up हो जाएगा. And this thing, na,
Yeah.
I think 2011 or 12, when I was in Hyderabad, I made a problem like this, close to each other. I did everything, and then बाद में पूरा bonus देना पड़ा. The problem is, if you keep close to each other, chalo, this and this potential you'll write. The biggest headache is this charge will start inducing charge on this surface. Conducting है ना? And if you take them as insulators, if you put a wire, charge won't transfer.
Yeah.
The whole problem was a mess. I made a paragraph like this in 2012 and 2011 or 12, and then a pura paragraph had to give bonus because the whole concept was wrong. So I had to keep it very far. If you keep it too close, they'll start inducing charges. And if they induce charges, pura, it will get messed up. I don't know how to calculate potential then.
Yeah.
It will not be uniform shell anymore. Your self energy will get destroyed.
Right.
That's a good one. That's the thing with keeping close. Which one?
Can you not ignore the induced charges?
Actually, maybe ऐसे ही argue किया था. We will ignore करके. But then you can't ignore it. The induction will be too much actually. So even if you ignore this, charge distribution won't be uniform, na?
Yes.
Meaning it was not a single problem. You can ignore one issue. That was creating so many issues. It was a mess. Because first of all, क्या होगा? If this potential will affect this potential will affect this. Second, charges will induce. If charges induce, the self potential due to itself will change. That was the second issue. Third, self energy will change. That is the third issue. You can't have so many assumptions. It's not chemistry and organic. Clear? Next one. So that's about self energy there. Next thing, relation between field and potential. We will wrap up the chapter on Friday, and we'll start off with Gauss laws. We'll finish off Gauss laws, and then we'll go to gravitation. Then we'll start waves. Field and potential. Gauss laws will be fun. I won't say it's not a toughest chapter, but उसमें कैसा है ना, it is not all numericals. It is like you have to keep on arguing with statements because it is like this, it is that, and that is this. Therefore, there is an answer. So it's a fun chapter. We will see. Ishan is doing secret chats. So let's see. So work done by internal conservative forces is minus change in potential energy. This comes from work per energy. This is work per energy statement. So work done is F bar dot dr. This is a minus Q into potential difference. So this is Q into E bar dot dr is minus Q dV. So we get dV is equal to minus E bar dot dr. We got quite a similar thing in work per energy. If you remember, relation between force and potential energy. So the first thing we have an integral form. VA minus VB is minus integral E bar dot dr. So this limits will go from A to B. If someone gives you field and they ask you potential difference, we can use this formula, integral form. So field is given by minus dV by dr, which is minus dou V by dou x I cap. Hope everyone remembers partial differentiation. Dou V by dou y j cap minus dou V by dou z k cap. This is your differential form. This thing, if potential is given and if they ask you for field, use this thing. So it's pretty straightforward. You see what is given and what is being asked. You give me E and ask me potential, use integral form. You give me potential, ask me field, use this thing. The most important thing, the negative sign here negative sign indicates in the direction of field, the potential decreases. Very useful statement, right? We will see later on. Meaning the more you travel in the direction of field, you can extract less and less energy. Think of like this. Let's say if you have a river flowing, and let's say this is the end of the thing, there's a waterfall or something. So if you tie a boat or something here, and if the boat travels from here to here, and if you tie a boat here and it travels from here to here, in which case are you doing more work? Or in which case do you extract more energy? Point A, right? The earlier you start, the more energy you can extract. That is the meaning of potential. When you say potential, the amount of energy you can take from A is more than B. So the more you go down the river, you'll extract less and less energy. Are you getting this? So if they frame a question like this, this is point A and this is point B. So can you tell me who has more field and who has more potential? They'll give a graph like this in the last, who has more field and who has more potential. B has more field now, because field ka definition is what? Number of lines per unit area. Who has more potential? A. Why? In the direction of field, potential decreases. This is a good level mains and bits level question. This is. Have a look at this. Take a break. Come back by 7:2. We'll continue from here. Utsa, did you get the doubt thing? Optics ka? You sent something now.
Yeah, I forgot it.
Forgot.
No, figured it out.
Figured it. ठीक है. Any doubts in today's class so far? Anything?
No, sir.
Chalo, come back in 10 minutes. हाँ
I
ईशान.
sent you a doubt on WhatsApp. वो टेस्ट था.
क्या था? एक बार टैग करो वापस.
1 minute ago.
Your name is not there only, right? Meaning after you sent, I think there are at least 70 messages.
So you're taking the test का doubts now.
We'll see in end. Photos तो भेजो ना. क्या doubts था उसमें? Photos भेज देना. We'll see end of the class. He said one doubt, तो I said I'll see.
You in one doubt.
वो diagrams नहीं है ना. The diagram missing you, I gave bonus for all of them.
So with this other wala question that I tagged right now.
Which one is this?
Center of gravity, center of buoyancy.
Center of gravity of the object, stable equilibrium. It's partial inside of the liquid. Center of gravity should be below center of buoyancy. That is right actually. You said choose the wrong option, na?
So why is it right? This center of gravity, how will it be below?
है किया रे हमने स्टेबिलिटी ऑफ शिप्स करके मैंने कॉन्सेप्ट नहीं सिखाया कहीं पे होना
You
चाहिए
were
stability.
taught, but
वही है ना बेसिकली इट इज द नॉनसेंस थिंग हियर stable and unstable equilibrium. Remember, if the ship has to be heavy at the bottom, stable unstable equilibrium concept था.
that's a like center of buoyancy is at the center of mass of the displaced liquid, right?
Center of buoyancy is the center of the mass of the buoyancy liquid.
And center of gravity is just the
Gravity is
center of-
actually center of mass only.
the center of mass will be above na, for the box. This you did for a ship.
है
But like
Nere, for any object, he's saying a solid object floats in a liquid lying in a container. The object is in stable equilibrium. So for stable equilibrium, center of mass has to be below the center of buoyancy force.
okay.
Ship या box क्या फर्क पड़ेगा? God.
No, like the it'll be at the center of the box, right? For a box, but for this it'll be like whatever that 2r by pi or
No,
So
don't
it's
worry about that box thing. End of the day, it should be above, it should be below. That's it. It can be left, right. That is okay.
okay, fine, got it.
Uh,
So I send it to you. WhatsApp.
क्या हो गया इसमें? Electrical charge identical drops. अरे ये था देखो कलर इसका कुछ नहीं है. We had to do this thing. ये एग्जाम में क्वेश्चन था. कौन सा एग्जाम का क्वेश्चन था ये? My exam.
No, sir.
Okay.
It was a 50
See
test.
na, so what you have to do, this is the point na, find the potential here. So when this charge becomes Q, find the potential here. So when this particle falls here, it should come to rest na. So V1 minus V2 into Q is equal to half mu square or mgh potential energy. You're starting from rest. If you're not entering matlab kya, you will come till here and you will fly back, isn't it? Matlab you're just coming to rest here na. So change in electrostatic potential energy should be equal to loss in gravitational potential energy.
हाँ वो सर +1 कहाँ से आया? I didn't get that in the answer.
अरे यहाँ पे जब डिस्टेंस लेंगे तो दिस इज r प्लस एच ना रे पोटेंशियल में
Okay, वैसे
क्योंकि
आएगा
भाई
क्या?
स्मॉल r
Or
r इज द डिस्टेंस फ्रॉम द सेंटर
-1 drop or something वैसे लेके.
कुछ नहीं है
Okay.
कैलकुलेट तो करो अच्छे से चल
So I tried, so nahi aaya answer. I sent you the working as well.
Chalo, camp on everyone. Let's say 43b is equal to xy square plus yz. Find electric field at 1 comma 1 comma 1. Get this. So potential is xy square plus yz. Find the electric field at 1, 1, 1. Try. Got a minute. Easy one. So dou v by dou x, when you differentiate with x, only x is variable, remaining a constant. This guy will be y square. Dou v by dou y, 2xy plus z. Dou v by dou z is y. So field is minus y square I cap. Substitute 1, 1, 1. So minus I cap minus 3j cap minus k cap. Easy? Yeah. Next one. Sometimes they'll not ask like this, they'll ask like this. They will say, this is the potential versus x-axis graph. Meaning that is when you travel along the x-axis, this is how the potential changes. That is Vy graph. Find the field in the region. So in a region, when you're traveling, this is how the potential changes with x-axis, along y-axis, along z-axis. If you see potential changes linearly, so field is constant. Let's see. Understand what is this? What is dy by dx? Dy by dx is nothing but slope in Vx graph, which is tan 30, which is 1 by root 3. Same way, dou v by dou y is tan 120, which is minus root 3. Dou v by dou z is tan 135, which is minus 1. So you're done. The field is minus dou v by dou x I cap. Most common mistake, people forget the minus sign. You just need to find the slopes and put a minus sign. Minus 1 by root 3 I cap, root 3 j cap, and k cap. Easy? Next thing. Find VA minus VB, where A is 1, 1, B is 2, 3. For different fields. Let's say field is x I cap plus y j cap. Field is y square I cap plus 2xy j cap. So now the electric field is not constant. The electric field is changing in the region as x and y. So for these electric fields, find the potential difference between A and B. See, how to do this thing? We have done this before. You know where? Work per energy. And I told you this will come again. Not here. Conservative forces में here. No, not this one. This one. Remember the question? Find the work done by the force when the forces are like this. These functions are called what? There's a name for them. Perfect differentials.
Conservative.
Perfect differentials,
Okay, yes, sir.
mathematical.
Yes, sir, got it.
So if you look at the formula here, so VA minus VB is minus integral E dot dr bar. So first one is xi cap plus y j cap dot product dr bar is dx I cap plus dy j cap plus dz k cap. So minus integral x dx minus integral y dy. Remember, a is the upper limit. That is x square by 2. That is 2 square minus 1, 3 by 2 plus 11 by 2. Now, when you try to do the
Yeah,
same thing for the
wait a
second
second.
one,
So what if you guess the function and then
guess the function, matlab?
like second one में you could guess ना कि किसका partial differentiation.
वो तो guess तो करना ही पड़ेगा, option नहीं है.
No, then why am I
Meaning,
getting the wrong answer?
क्या guess किया exactly? देखते हैं, देखो. तो y square I cap plus 2xy j cap. वही दिया ना मैंने? Yeah. Maybe you guessed it wrong. Tyj. So basically, when you try to integrate this, you can't integrate each term separately. Remember, y is also variable. So y square dx plus 2xy dy. So this is minus integral d of xy square.
I guessed it right. Wait, eight.
Understood? So you're not integrating the whole thing, you're integrating xy square as a function.
Okay.
Got it? So you can do like this if you want. You can say put xy square is equal to t. So T A will be 1, 1. So that is 1. T B will be, because A is 1, comma 1 and B is 2, comma 3. That is 2 into this thing. So 18. So basically this limits will be integral dt. This is the limit of TA and this is the limit of TB. So 18 minus 1, so 17.
Yes, sir, I got that one right. The पहले वाले में if I guess the function, it would be xy, no?
नहीं रे, वो x dx and y dy क्यों करोगे उसमें? उसमें परफॉर्म यही ही नहीं. That you are saying that is y dx plus x dy.
xy would be right, ना? अगर partial differentiate करें.
है. This one.
एक second. हाँ.
नहीं रे.
एक.
ये
हाँ.
y dx plus x dy होना चाहिए.
Oh, right. Wait.
इसका क्यों करना है? ये perfect differential नहीं है ये. You can separate them individually.
हाँ. Yes.
Everyone have a look at this. Do you remember this question? We have done this in work per energy. So you can, for more things on this, you can refer work per energy. Page number. That's what I'm saying. If you can connect stuff like that, you will not find it overwhelming. 23. There we did even more weird equations. Clear? Turn in the page. Swastika, Palaksh, clear with this? Aryan, Ali, Anika? Great. We have an infinite line charge. There's a point here and there's a point B here. This distance is R1 and this distance is R2. To find VA minus VB. This was easy. So what is the electric field due to infinite line charge? 2k lambda by r. So VA minus VB is minus integral 2k lambda by r dr. Limits will go r1 to r2. That is 2k lambda ln r2 by r1. Straightforward. One step. There's nothing there. Easy one.
That will be ulta, na?
ये minus sign है ना बाहर.
Oh, sorry, you asked VA minus VB.
Clear? Next one. Now I'll give you some statements. You have to tell me which are right and which are wrong. E is 0, V is 0. मतलब and E is 0 and V is 0. E is 0, V is not 0. E is not 0, V is 0. E is not 0, V is not 0. Which of the following are possible? Meaning both of them has to be satisfied.
So I said,
नहीं. Ishan, हाँ, you're right. Me, Anika, Anusha, Aryan, Saina. Let me ask you something more. Let me add a few more points. I think then you'll get an idea. E is 0, dV is 0. E is 0, dV is not 0. E is not 0, dV is 0. E is not 0, dV is not 0. The biggest mistake what people do, dV and V are not same. Try to understand the relation. Field is minus dV by dr. It is not V by r. So look at the first one. E0, V0. Possible? Don't keep any charge, na? If you have no charges, E is 0, V is 0. E0, V not 0 is possible. Any example? If you take a hollow sphere, inside field is 0, but V is kq by r. E is not 0, but potential is 0. Possible? If you take plus q and minus q, exactly at the center, V is 0, but field is not 0 because they will add up in the same direction. The mistake you guys did was you thought अरे V0 तो E0 होना चाहिए. Tell me one thing, if you have potential like this, -1, 0, +1, 2, 3. V0, but is change in V0? I hope you're getting the mistake. V0 does not imply E is 0. Change in voltage should be 0. If the values are changing -2, -1, 0, 1, 2, 3, V becomes instantaneously 0, but change in V is not 0. This though is anywhere fine. And now here it comes, see, if dV is 0, E has to be 0. This is definitely wrong. If E is 0, dV has to be 0. So this is what we say. If dV is 0, then there is nothing there. E has to be 0. So this guy is gone. This is right. So the most important thing here is V and dV are completely different. It's like saying if velocity is 0, acceleration is 0. Does it make sense? When a particle is thrown into air vertically at the highest point, velocity is 0, but acceleration is not 0. Clear? So if I had given only these 4, answer is all 4 are right. So be careful with that. Because the moment you see E and V, you think that only. V is 0 to E is 0. Easy. Next one. Next thing. Equipotential surface. So the word itself explains a surface or the region where the potential is same. So example, if you take a shell, the entire inside V is KQ by capital R. This is an equipotential region. The entire region has same potential. But if you go outside and if you try to draw concentric shells, so this shell ka potential is some KQ by R1. So this is a equipotential surface. If you take another shell, this is also equipotential surface, but a different potential. So each shell is an equipotential surface. I hope you're getting it. So here the concentric shells are equipotential. So each shell is equipotential surface. If I take one more example, let's say infinite line charge. So here the equipotential surfaces are cylinders, coaxial cylinders. Each cylinder is an equipotential surface. Can you give me another example? Solid sphere will be same as hollow shell. Suppose if I take plus Q and minus Q, is there any equipotential surface?
Yes, so the perpendicular bisector.
No, there is something better word you can use. You're not wrong, but there's a better word. Aryan. The entire perpendicular bisector plane. You're getting it? The entire plane in the perpendicular bisector is equipotential. Because no matter where you take equidistant, the potential is always 0. So from here, if you choose a point here, choose a point here, V is 0. So this is a plane along perpendicular bisector, or you can simply say perpendicular bisector plane. You're getting it? So if the potential is same, it is called equipotential surface.
So is this like fluids ka? I think we also
Yeah.
did.
Yeah, fluids ka
surface
kya?
across which the pressure is constant. Is it similar like that?
Come again?
A surface across which the pressure remains constant in the fluid.
What is
fine?
it called? क्या था वो?
I don't know what it's called
There is
exactly.
ऐसा कुछ है ही नहीं. At least I तो didn't teach anything like that. Equipotential pressure surface ऐसा कुछ? Equipressure surface.
हाँ sir, kind of. We did it in class.
कुछ नहीं रे. That was what? In the horizontal level, pressure is same. बस वो statement था वो. Isn't it? If you take a liquid in the horizontal direction, the pressure at the same horizontal level will be same.
For fluids which also rotate and which also accelerate in a direction as well.
तो
Okay.
कहीं पे देखा होगा ना? भेजो देखते क्या है.
Okay, sir, I'll find it.
Find it. Clear with this? So, what are the properties of equipotential surface? This entire thing, right? A field and potential, exactly same thing you will see in gravitation. Nothing changes because the symbols are same. The first one, work done in moving a charge on equipotential surfaces is 0. Obviously, because the change in potential is 0. That means you can move on these equipotential zero surfaces without doing any work. So this thing actually, right, NASA and all these satellites orbits, right, whenever you're launching something from one point to another point, this becomes very important. Just imagine you have Earth, you have Moon, you have Mars, Jupiter, and everything. Because of all these things in the system, which is actually quite complex to calculate, we use supercomputers, which might take some months of time to calculate because of multiple things. So if somehow you can find an equipotential region or equipotential curves. So if you want to go from Earth to Mars, the best thing to do is from Earth reach this equipotential line and travel on this line. You need not use any fuel in this region. And then you take a detour and go to Mars. So this way you can conserve a lot of fuel. So, and there are certain points in equipotential planes. There is a name called Lagrange points also. So वो orbits का है. But this is that's what they do for supercomputers. They use supercomputers to calculate trajectories where if you can find the points of equipotential and if you travel along them, you will save a lot of energy. That is what we do there. We don't do something similar, but aeroplanes, right? There is something called slipstreams. Ever heard about it? It is like if water flows on the earth, we call it river. In atmosphere, when there are air currents, we call it slipstreams. You're getting it? So there are air currents which are flowing in the atmosphere, maybe because of Earth circulation or something, they call slipstreams. So if you can take your aeroplane in the slipstream, if the slipstream is going with a speed of 80 kilometers per hour, your aeroplane will get an extra speed 80 kilometers per hour. Free of cost, you'll get extra speed. Disneyland moves, yeah. So actually, there is a company, which actually keeps track of the streamlines, the slipstreams, and they sell the data to aeroplane companies. Airplane companies love to buy the data, and you keep on updating data on daily basis or weekly basis. Because every time the plane speed goes to 80 kilometers, even if you add 50 kilometers per hour, and if you can reach the destination faster, you can save a lot of fuel. The biggest expense in aeroplane ticket, you know what is fuel? Next time when you aeroplane ticket, na, उसमें देखो fuel surcharge करके होगा. India में तो it is more hopeless. Almost 50% of the ticket cost is fuel only. Actual fuel का cost is 15%. उसमें taxes are 30%. That is the reason India में aeroplane companies go bankrupt. Next thing. So there was a joke actually. If you want to be a millionaire, start with a billionaire, be a billionaire and start an aeroplane company. You'll become a millionaire. If you want to be a millionaire, first be a billionaire, then start an aeroplane company, and then you'll become a millionaire. Example, Vijay Mallya. So electric field lines are always perpendicular to the equipotential surface. Why? Think about it. Suppose if this is your equipotential surface, and let's say we have a field like this. So if you have components like this, E cos theta and E sin theta. Remember, we wrote a definition. In the direction of field, potential will change. So in the direction of E cos theta, the potential should change. Basically, tangential direction. But you said this is an equipotential surface. Since it is equipotential surfaces, field should be 0. You cannot change the potential. Theta has to be 90. So if you take a best example, the point charge ka thing, if you observe how are the field lines are radial. And how are the equipotential surfaces? This is an equipotential surface, and if you see they're perpendicular. So if you have an equipotential surface, the lines have to enter perpendicularly and leave perpendicularly. There's no way out. Clear? The third point, equipotential surfaces do not cross each other. Same reason, again, you'll have two directions of field. There are the three properties of equipotential surface. So if you have two equipotential surfaces like this, you have to be perpendicular to this guy and you have to be perpendicular to this guy. You cannot have two electric fields at the same point. Yeah. Let's see a question. Any doubts on this page, please ask. Let's try this question. So we have 2 point charges Q1 and Q2 occupy fixed positions. Every point on the curve surrounding charge shown in the figure. So basically this line which is drawn is an equipotential surface. Whose potential is 900 volts. Then the question is find the distance between the charges.
वो सब nano coulomb है ना, the charges?
N is nanocoulomb. If someone gives you like this 1 mu c, it's a microcoulomb, 10 power minus 6. 1 mc is 10 power minus 3. 1 nc is 10 power minus 9. Let's get this question. It's a good one. Now, first thing, right? When you see this question, the first problem is this point. Just now we wrote a statement, equipotential surfaces do not cross each other. And now you're telling me they're crossing.
The field must be zero at that point.
You keep quiet, Nari. This I have to tell you 10 times. You got something answer na in the chat box. Why are you revealing it? It's like, you go to a magic show and you tell them, abhi dekho pigeon aayega. Abhi dekho movie mar jayega. Abhi hero mar jayega. Abhi dekho heroine will fall into this thing. People will beat you in the movie theater if you keep telling everything. You got something, answer it. You saw now. See, I would have asked everyone. Now they're not thinking. ठीक है. Forget about what Ishan said. You all have memory loss. So then we thought the thing is, look at the statement here. It is important to think that way. The statement says you cannot cross each other. That is no doubt about it. But this question also says they're crossing each other for sure. So let's try to think about it. What is the problem if you cross each other? You will have
Right.
two directions of field, right? So think about it. Can you have a vector which can have two directions? Zero vector. A zero vector is undefined direction, isn't it? It's like saying the number is not positive, the number is not negative. Means what? It is zero. You're getting the point? So the only possibility when the equipotent surfaces cross each other is the point of intersection must be a null point. Clear? So that is a counter for the third statement. So if you cross, that is the only possibility. At the point of intersection, we cannot have two directions of field. Therefore, field has to be zero. That is the only possibility. There are multiple directions of field. The only vector which satisfies that condition with multiple directions is zero vector. Finally, we use that zero vector once in its life. Multiple directions. Therefore, field has to be zero. So basically, we got that point is null point. Zero vector has undefined direction. And that's it. Once you figure out question kuch hai hi nahi tha. This guy was R1. This guy was R2. So first thing is potential, which is KQ1 by R1 plus KQ2 by R2 was 900. The second thing, it's a null point, so field is zero. So KQ1 by R1 square is KQ2 by R2 square. This is your equation to solve, and you'll get answer from here. R1 and R2 the values you'll get. Distance between them is R1 plus R2. 0.09, yeah? Okay, so answer is 9 centimeters, it seems. Clear? So that would be the first confusion, like how are they crossing each other? So there's only one possibility. All got this? Any doubts on this? Clear, na? Arjun, Vartika, Rehan,
Yes.
Neil, Palaksh, Yasha, got this? Perfect. We have shells, we like this, we have concentric equipotential surfaces. So this potential is 60 volt and distance is 10 centimeter. This potential is 30 volt and the radius is 20 centimeter. This potential is 10 volt and 20 volt and 30 centimeter. So radius and potential is given. Find the field in the region. This is a HCV equation. So three equipotential surfaces are given. So they gave you the potential of that shell and the radius of the shell. Using this data, you need to figure out the field in the region. Two things, you need to find the magnitude as function of distance and you need to find the direction also. Can someone tell me the direction? That's the easiest one.
Radially outward.
Radially, now first thing, it should be perpendicular, but the doubt is inward or outward. How do you decide that?
So do I see? Yeah, chat box.
Chat box, always the chat box. We don't want people who will come in the movie theater and tell the thing that hero is going to die. Just imagine, Avengers movie to gaya, right? And now you're going to shout, Abhi Captain America will take the hammer and hit him. That was the biggest thing in the entire movie, and you shout before the movie, you're going to get killed. Remember the statement, in the direction of the field, potential decreases. Yeah. So here the potential was 60, here the potential is 30, potential is 20. It is decreasing now. So field should have been outward. Make sense? And it should be perpendicular to the surface. So it should be radial, that much we know. And it is outward. Try. Yeah. Right, Asha, you got it. Saina got it. वो यूनिट्स देखो ना, सेंटीमीटर डिस्टेंस है अनुषा. Yeah, just give it a try. Now, if you observe something here, there are two ways you can handle this. The first thing was V into R was constant. Did you observe that? That is one way to do the problem. You can notice V into R is 6. So V is equal to 6 by R. So therefore field is equal to minus dV by dr. And that would be 6 by R square. That is one. Second alternate, you can argue this kind of potential is possible for only point charge. Isn't it? This is a point charge or a hollow shell or something like that. These kind of shells, these kind of surfaces are possible for a point charge or a shell or a solid sphere in the center. So you can assume a point charge q here, and you can say kq by 0.1 is 60. So you will get kq is equal to 6. Observe, for everything you'll get the same thing. Therefore, field is equal to kq by r square, 6 by r square. Either way, you will get it. And the field has to be radial, so perpendicular to the surface and away, since potential decreases radially. So then once you got the idea, it's a point charge, it becomes easy to solve. Easy? Check it out. So you can do that V into R, or you can figure out it's a point charge. Same thing, another similar model. What if you have equipotential surfaces like this? Planes. So this point is 10 centimeter, 0, 20 centimeter, 0, 30, 0. And these angles are 30 degrees, 30 degrees. And these potentials are, this is 10 volt, 20 volt, 30 volt, and 40 volt, so on. These are equipotential planes. Find the electric field in the region. minus I cap mere. What was the direction of the field? Perpendicular
Yes,
to the
sir.
plane. So it has to be perpendicular to the plane. Which way? Up or down? Right or left? In the direction of the field, potential decreases. So this guy, na?
हाँ नीचे
और magnitude कितना होगा? You can take so this is the perpendicular distance. So EV magnitude is delta V by delta R. So potential difference is 40 by. So this distance is 10 centimeter. So this is 10 sine 30. So delta is the perpendicular distance between the planes. So that is 10 sine 30. Don't write 10.
So delta V is only 10 now.
Sorry, 10. Yeah. So that is 2. Got it? So magnitude is 2, which is constant and the direction is this way. If I have to draw, I'll just draw it again. See, so this is the plane and this is the plane. This distance is 10 centimeters. That is not how you take distance between two parallel lines. This is the perpendicular distance. Now, this is 5. Actually, I did one more mistake. वो centimeters में gods. So 200 तब. This is 10 centimeter, that is. So be careful. V is equal to 10R. You can't do that, right? These are planes, na? It would have worked out even then. But it is 10R, kya? But your R is different, isn't it? But it is not
Equal to what?
Why? V is not 10R actually. It's not. What is R? R is a radial distance, right? It doesn't make sense, right, Saina? Okay, so that's the last one for that day. So the next class when we meet, we are going to do dipoles. That now see till now what we did, everything is there in gravitation. Dipoles is not there in gravitation. That is one thing different in gravitation and electrostatics. We don't have satellites here. We don't have dipole there. And dipoles is not tough, but if you ask me, it is more of a mathematical concept than physics. But quite an important one because the same thing will again repeat in magnetism. So ideas are same, the logics are same, and is not tough, but yeah, it is a little confusing. You have to be careful with the math part. So we will see that in the next class. Mostly we should be able to wrap up, and if you're done early, and then we'll start off with Gauss law introduction in the next class. Okay, so with that we'll wrap up for the day. So we have done almost 49 problems so far. So please make sure to check out all these problems and start doing. Don't wait for me to finish the chapter. If you're doing HCV, you can start finishing it off. Except for the last 4 or 5 questions, we have done everything. Right. The reason to do Gauss law is because I think most of your booklets, right, has electrostatics and Gauss laws together. So let's finish it off so that you can finish your material. Then we can go for Gravy. So it is mixed up in most of the cases. But in HCV, they're given separately. So yeah. Okay, with that we'll wrap up for the day. So
And
how
the
it's
capacitance वो कब होगा?
capacitor is
हाँ,
अभी कितना time लगेगा?
after waves we'll do capacitors.
Okay, because we have like